So far, we have investigated value estimates for specific natural resources or ecosystem services. And as pointed out by Núñez and van den Berg, much of the literature on the economic valuation of biodiversity is actually about the value of biological resources, and it is linked only tenuously to the value of diversity. By contrast, Weitzman considers the valuation of diversity explicitly. In a paper called The Noah's Ark Problem, he asks how best to preserve diversity with a limited budget. A relevant question, especially given the insufficient conservation budgets. Weitzman argues that Noah's ranking R for species I can be thought of as expected marginal distinctiveness plus utility per dollar, where delta P captures the increased survival probability from a project at cost C. U subscript I captures the direct utility of a species I's existence, which can vary by species since most of us like orangutans or pandas better than mosquitoes or snails. D subscript I is the diversity value, which is the focus of Weitzman's paper. The intuition here is that species may be considered more or less distinct from others in terms of their position in a phylogenetic tree and thereby may hold more diversity value. Although it may still be difficult to translate the cost-effectiveness study of orangutan conservation by Santika and colleagues to increased survival probabilities, the study is informative about this delta Pi over Ci for orangutans. Let us briefly inspect some highlights of this study by Santika and colleagues. The authors combined field surveys with interviews with people living near orangutans to gather data on probability of orangutan sightings. Santika and colleagues subsequently translated the probability of occurrence data to density estimates. This was done by assessing the correlation between the predicted orangutan probability of occurrence and the density rates calculated directly from the orangutan transect data over grid cells where transect surveys were conducted, producing these maps from their supplemental material. The authors matched their orangutan density estimates to detailed data on investments in conservation activities. The maps show how investment changes over time and location. The histograms show that investments are organized in 6 categories: habitat protection and acquisition, habitat restoration, patrolling and law enforcement, rescue and rehabilitation, reintroduction and translocation, and public outreach and awareness campaigns. The top panel shows different investment patterns by region, and the bottom panel estimated the cost effectiveness of these different conservation activities. It is encouraging to see that all types of activities show positive returns to investment in terms of improved probability of occurrence as compared to the authors' their estimated counterfactual scenario of no activity. The cost effectiveness estimates can be useful to guide future conservation investments, but the same type of drawbacks that we saw when discussing marginal abatement curves last week apply here as well. That is, there could be larger conservation co-benefits to habitat protection and, say, awareness programs, or larger scope for learning in ecosystem restoration. Weitzman later applied his idea to the conservation of cranes, where he relied on expert opinion for input to the different survival probabilities and phylogenetic tree distance of the crane family. Weitzman, his analysis suggests that, perhaps counterintuitively, the analytical preservationist favors making the safe species safer at the expense of making the endangered species more endangered, because a whole line may therefore be made safer. Continuing this seeming paradox, Other things being equal, the strength of this effect is greater when there is a longer time horizon or a lower discount rate. Well, I believe this thought exercise by Weitzman is useful. For example, it helped me formulate an interpretation of my map with expected extinction rates. I doubt its value in direct application to conservation policy. Perry presents an excellent critique that Weitzman's arc would give a biodiversity of cute, fuzzy, enormous, unique, and bizarre species favored by humans. Weitzman's ranking ignores ecological importance of species and interdependencies such as pollinators or predator-prey relationships. Perry suggests to replace utility and phylogenetic tree distinctiveness by contribution to ecosystem functioning. Based on his alternative ecological importance score, so-called keystone species that perform unique functions receive the highest weights. The paper illustrates how this would lead to a different conservation priority with an example of the northern spotted owl and the Delhi sands flower-loving fly. Owls are iconic species with likely a high utility of conservation. Yet some close relatives are relatively safe and it seems of little ecological importance. Its functions are also fulfilled by these relatives. By contrast, the flower-loving fly has less charisma but is the only pollinator in a sand dune ecosystem in California. Which species should reserve a higher conservation priority? Can we introduce some of the lessons from this cost-effectiveness analysis on species conservation to help inform us on cost-benefit analysis? This brings me to my reply to the question of how to determine the benefits of a beaver. First, I made sure that we were talking about the same species, Castor feber or Eurasian beaver, and then I verified whether it is true that beavers are ecosystem engineers like ants and ourselves. Next, I argued that the benefits of a beaver could then arguably be expressed as the ecosystem services provided by the ecosystems beavers create. The earlier shown estimates by Costanza and colleagues suggest that the wetlands that beavers create are potentially more rare and valuable in ecosystem services per hectare as compared to the more plentiful forest they replace. Another example where my solution to the beaver problem as expressing the benefits of a species conservation in ecosystem services may be found in vultures that deliver scavenging services. However, I am doubtful whether expressing the benefits of a species conservation in ecosystem service can be meaningfully translated to the scale of ants or other micro-ecosystems.